So for this week, we will discuss about Unit 10, which is all about the inheritance. So one of the greatest benefits of the object-oriented approach to software development is that it offers the opportunity for us to reuse classes that have already been written either by ourselves or by someone else. So in our module or earlier modules, we discussed about the inheritance, and it is the one of the important concepts in object-oriented programming. And also, we know that if there's a relationship, or specifically the inheritance, meaning to say that uh, the child class will inherit all the properties, so the variables or the behavior of the other class into its implementation. So let's take a look at a possible scenario. Say you wanted to develop a software system and you have during your analysis identified the needs for a class called employee. So let's just say we have an employee class, and you might be aware that a colleague in your organization has already written an employee class. Okay, so you could think of this as a duplicate class. You want to create a class named employee, but suddenly you discovered that one of your colleague or one of your co-employee in your organization have already written the employee class. So rather than having to write your own class, so it would be easier to approach your colleague and ask her or him or her to let you use her employee class. So far so good. But what if the employee class that you are given doesn't have or doesn't quite do everything that you had hoped? So for example, there's a missing feature or behavior, or let's say property, that is not present on the existing employee class. So perhaps your employees are part-time employees and you want your class to have an attribute like hourly pay, or methods like calculate weekly pay and set hourly pay, and these attributes and methods do not exist in the employee class you have been given. So for example, you approach your colleague or someone who had created the employee class, and then only to find out that there's a missing properties on that class. Okay, so some may think it would be necessary to go into the old class and start messing about with the code. So, but there's no need, because object-oriented programming language provides the ability to extend existing classes by adding attributes, methods to them, and this is called the inheritance. Okay, so here, so inheritance is the sharing of attributes and methods among classes, and then we take a class and then define other classes based on the first one. Okay, so the new class inherit all the attributes and methods of the first one, but also have attributes and methods of their own. Okay, so aside from the um, inherited attributes and methods, so we could also add some more feature to our class. Okay, so let's try to understand this by thinking about the employee class. So using the UML from our early modules, so we have here an employee class. Let's say this is an existing class from your friend or colleague. So it has an attribute number, which is a string, I'm not sure why, and then name, which is of data type string. Okay, and then we have a constructor here, employee, which takes two strings as a parameter, and then we have a set name attribute or behavior, and then get the string, get number returns a string, and then get name that returns a string. Okay, so here your class is the part-time employee, and then it has hourly pay, which is of type double, and then it has a behavior part-time employee, so string string and then double. So this is a constructor, and then set hourly pay double, so it would accept a double as a parameter, and then set hourly pay with the double return type, then calculate weekly pay int with double return type. Okay, so what's next? So as you could see here, we have an inheritance, meaning to say that even if we don't write it on our part-time employee, this number and name together with the attributes, I mean the methods or behavior would also be present here in our part-time employee. So we just reuse the code in our employee class to our part-time employee. So for example, you have created a um, part-time employee instance of this class. So we could still use the set name or get number from the employee. So meaning to say, using the object of part-time employee, we could call the get number or set name from this class. So for example, we have created, let's say, PTE for part-time employee is equals to new uh, part-time employee. Part-time, oops, okay, and so on. So we just created a part-time employee, and then so this is the object of part-time employee. And then we could also use the methods from our employee class, just like this. PTE, then let's say get number. That get number. Okay. So just like that. Even though it's not present here in our part-time employee class, we can still use the get number from the employee. So first it goes from here, and then your compiler, since it can't read or let's say evaluate this class, you could think of the compiler would check its parent class to see if there's a get number. So from here, and then if the get number method is not present here in this class, the compiler would check the get number to its parent class, which is in our employee. Okay. So after that, say our employee class has two attributes, number and name, and a user-defined constructor, and some basic get and set methods for the attributes. So we now define our part-time employee class, and this class will inherit these attributes and methods, but can also have attributes and methods of its own. Okay. So we will give it one additional attribute, hourly pay, some methods to access this attribute, and one additional method, calculate weekly pay. Okay. So just the implementation. And this is illustrated using UML notation for inheritance. And you can see from this diagram that an inheritance relationship is a hierarchical relationship. Okay, so the arrow points to our employee class, meaning to say that our employee class is the parent class. Okay, and the one that would inherit the properties of the parent class is the part-time employee. Okay, so you can see the head and the tail of the arrow. So once the arrow points to a class, meaning to say that's the parent class. Okay, so you can see from this diagram, inheritance relationship is a hierarchical relationship, and the class at the top of the hierarchy, in this case the employee class, is referred to as the superclass or parent class or base class, and the part-time employee as the subclass or derived class, so, or child class for some other sources. So but it's just the same thing. The inheritance relationship is also often referred to as an is a kind of relationship. So in this case, part-time employee is a kind of employee. Okay? So I mean to say it's one type of employee. Next, so here's the implementation. So you may try it out on your machine. So the code for the employee class is shown below. Shown below. So we have the public class. We just convert this UML diagram into an implementation of code in Java. So we have public class employee, and then private string number, private string name, and then public employee. This is the constructor. Okay. So public employee, so same name as our class, and then string number, what's this, in or ln, not sure, and then name ln. Okay, Then number is equals to number ln, and name is equals to number name ln. Okay. So public void set name. So we'll just set the name of that variable name if we set, or if we use the set name method, and then pass the new name to its parameter. So the name would be set to a new name. Okay. Then public string get number. So we'll get the number. Okay. Set from our um, implementation of the constructor. Okay. So the number, we'll get the number once we created the instance of this class, okay, through the use of the constructor. And then public string get name. So we'll just return the name. So if you haven't set the name, so the default name that would be displayed is the one that is transferred to our constructor, since we are using this as an initialization of number and name. Okay. So there's nothing new here. So let's get on with our part-time employee class, and I will present the code first and analyze it afterwards. Okay, so here's uh, the class for part-time employee, which extends. So we have the keyword extends employee. Okay. Now, again, we will just create our attribute, or let's say the variable hourly pay, which is of type double. So we just declare, and we haven't assigned a value to it. And then public part-time employee. So this is a constructor. So this constructor accepts string number ln, string name ln, double hourly pay ln. Okay. And then inside the implementation, we have this super. So meaning to say we have from our super class. So we have number ln and then name ln. Okay. So what does this super mean? So meaning to say it calls the super class. And which one is the super class? It's the employee class. Okay. So well, you could actually analyze this one. This just a setter and getter and an additional method calculate weekly pay. So but this one is also a keyword, meaning to say we're passing the number ln and name ln to our employee class. Okay. So this is a constructor of our superclass. So meaning to say this number ln here from the part-time employee class will be accepted inside the constructor of employee class. Same goes for the name ln. So it's ordered from number ln to name ln. Okay. So it should also of the same type. So if this is a string, this too should also be string. Well, of course, this is a string based on the declaration of this constructor. Okay. So again, the implementation of the methods of the part-time employee. So it's just like this: public. So this is the return type. Double get hourly pay. So hourly pay is double. So I mean to say this is accepted. And then void, so I mean to say we were not going to return anything. And then the name of the method is set hourly pay. And then we have the double hourly pay ln. Okay, so we'll just set the hourly pay into equal to hourly pay ln. Okay, and then the next one is public double calculate weekly pay int number of hours ln. Okay. So since this is double, we'll just return number of hours ln times the hourly pay. So this would give us a double value. Okay, so return double. Okay, so the first line of interest is the class header itself. Okay, so here we see the use of the keyword extends. This one. So using this word in this way means that the part-time employee class, the subclass, inherits all the attributes and methods of the employee class, say the superclass. So although we haven't coded them, any object of the part-time employee class will have, for example, an attribute called name and a method called getNumber. A part-time employee is now a kind of employee. But can you see a problem here? So that's the question. Can you see a problem here? The attributes have been declared as private in the software class. Okay? So although they are now part of our part-time employee class, none of them or none of the part-time employee class methods can directly access them. Okay? So the subclass has only the same access rights as any other class. Okay? So meaning to say, you cannot directly change this to without going past through the constructor. So that's why we use super to edit the values inside the string number and then string name. Now, there are a number of possible ways around this. So we could declare the original attributes as public, but this would take away the whole point of encapsulation. Okay, so we want to protect our attributes from um, other classes so that they won't be able to access the attributes directly and change it unintentionally. So there are some cases that you might want to change something or let's say modify a variable from another class, but suddenly we encounter some unexpected result. So maybe we have accidentally updated something that is not that shouldn't be updated in our program as we go on. So the whole point of encapsulation is to protect the variables from um, an intentional update, or let's just say modification of the values inside those variables. And then we could use the special keyword protected instead of private. So the effect of this is that anything declared as protected is accessible to the methods of any subclasses. So there are, however, two issues to think about here. So the first is that you have to anticipate in advance when you want your class to be able to be inherited. And then the second problem is that it weakens your efforts to encapsulate information within the class, since in Java, protected attributes are also accessible to any other class in the same package. So meaning to say, it's just like you're limiting the number of classes that could access the attribute, but still it's at risk since um, classes on the same package, or meaning to say, uh, if other classes extends the employee, they could also access the attributes. Okay, so those who are not included in the same package, or let's say those class uh, who haven't extend their class to employee, so they cannot access the attributes. But there are other classes that might extend the employee class, so they can access those attributes using their methods, or let's say using different implementations in their program. So the above remarks notwithstanding, this is a perfectly acceptable approach to use, particularly in situations where you are writing a class as part of a discrete application. So meaning to say, uh, if there are uh, contributing classes to each other. So for example, there are one class that is considered as parent, and there are multiple child classes that works together in order to run the application. So that's why it's a discrete application. And then, and you will be aware in advance that certain classes will need to be subclassed. Okay, so uh, most of the time in the industry, a class may have two or more classes or subclasses that works together in order to form an application. So it's inevitable. They should work together. That's the essence of object-oriented programming. We use different classes in order to work together to to give the best application in to its user. Okay, and then the other solution, and the one we will use now, is to leave the attributes as private, but to plan carefully in advance which get and set methods we are going to provide. Okay. So next is the after the class header, we have the following declaration: the private double hourly pay. So this declares an attribute hourly pay, which is unique to our subclass. But remember that the attributes of the superclass employee will be inherited. So in fact, any part-time employee object will have three attributes. Okay, it's not just hourly pay. So next comes the constructor. So we want to be able to assign values to the number and name at the same time, or at the time that the object is created. So just as we do with an employee object, so our constructor will need to receive parameters that will be assigned to the number and name attributes. So but wait a minute, how are we going to do this? So the number and the name attributes have been declared as private in the superclass. So they aren't accessible to objects of the subclass. So luckily there's a way around this problem. So we can call the constructor of the superclass by using the keyword super. Okay, so look how this is done. So we have the public part-time employee a while ago. So string number ln, string name ln, and then number or double hourly pay ln. So here the super, so if we're going to rewrite this one, so it's the same thing as the employee. Okay. So employee, okay, then number ln, okay, and then the name ln. So it's just like, oh wait, so here's the new keyword. So in our constructor, um, we have the employee. So the employee accepts the number ln as a string and then name ln as a string. Okay, but since we are in the part-time employee class, and part-time employee class is a child class of employee, so we could use the super class instead of creating a new instance of new employee. We just need to use the super keyword and then pass the number ln and name ln inside the superclass. Okay, so this is definitely, or this is actually the constructor of the employee class. So in the constructor of employee class, it accepts number ln as string and name ln as a string. So we could actually pass this two parameters inside the super keyword. Okay, so calls the constructor of the superclass, which is the employee. And then another one is hourly pay is equals to hourly pay ln. So where did it come from? Okay, so it's here. It's also included in our constructor of part-time employee. Okay. So next, after calling the constructor of the superclass, we need to perform one more task. So namely to assign the third parameter, hourly pay ln, to the hourly pay attribute. Okay, so this one. So notice, however, that the line that calls super has to be the first one. Okay, so if you're going to access the constructor of the superclass, it should be at the top or at the first line of your constructor or any implementation of the superclass. So it should be on top. Okay. Here, the remaining methods of part-time employee are now are new methods specific to the subclass. So we have the get hourly pay. So it would return the hourly pay. Public set hourly pay, double hourly pay. Okay. And then calculate weekly pay. And then return number of hours hourly pay. Okay. So the first two provide read and write access respectively to the hourly pay attribute. So meaning to say, when we say read and write, so read meaning to say we're just gonna access the value of hourly pay. So that's why it's called get. So we'll get hourly pay. So if it's just like you're asking what is your hourly pay. Then the first two provide read and write access respectively to the hourly pay attribute. And then the third one receives the number of hours worked and calculate the pay by multiplying this by the hourly pay. Okay, so as you can see here, so it says the two keyword, the read and then the write access of the hourly pay attribute. So when we say read, so this usually starts with get. So get and set, getters and setters. So get hourly pay. It's just like getting what is your hourly pay. For example, I ask you, what is your hourly pay? So we're reading. We want to ask, what is your hourly pay? We're getting your hourly pay. So what is your hourly pay? So that's why it's called the get hourly pay. So you would return, if you're the one that is being asked, you will return your hourly pay. So what is your hourly pay? It's 800 per hour. Okay, so something like that. And then set hourly pay. So that's the right access. So meaning to say we're gonna set your hourly pay. For example, I'm going to have a talk to you, and then I'm gonna say, okay, so your hourly pay would become 950 since you are promoted. So set hourly pay. We will set your hourly pay, but how much? So it's in our parameter. So double hourly pay. So meaning to say, if I'm going to use this set hourly pay from our part-time employee, so let's just say PTE dot set set hourly pay. So hourly pay. So that's set hourly pay. Then inside is the, so double should be decimal. For example, 950.00. Okay. So this would become the hourly pay from the PTE class would be set into 950. So the previous value will be replaced by the value that is being set in our PTE, which is our hourly pay LN. Okay. And then the next one is the public double. Well, actually, this doesn't have to return anything since we're just gonna set hourly pay. Okay. So public double, calculate weekly pay. So this one accepts a parameter number of hours ln. So here we will return a double value. So what is the purpose of number of hours? Well, of course, for example, I'm gonna ask you how much work did you render for this week, or for example, how many hours of work have you contributed in our project for this week? So for example, you have contributed at least 8 hours a day, so that's for example 5 days, so 40. So 40 hours. So you will multiply the 40 times the hourly pay that is set in our previous method, or let's just say the default value of the hourly pay from our constructor. So we'll just multiply that and then return it to our caller. So for example, we have PTE that calculate weekly pay. So it would return the number of hours ln times the hourly pay. Okay. So since we have the return type. Okay. So here is an example of the program demonstrates the use of the part-time employee class. So employee number. So we have something like this, and then employee's name, monthly lifeboats, hourly pay, 15.5 dollars. Let's say dollars. It's this too small. 15.5, and then hours work this week. So let's say 20. So this would generate an output. So these are user inputs. These bold letters here are the user input, and then it would display the name. So emp.get name. So this would display Mandelife boats. Emp.get number. So this is the number of the employee or employee number. Ah, I see. So that's why it's a string, because it's a alphanumeric, meaning to say it's a combination of letter and number. So if you're going to work with an alphanumeric, might as well just declare the variable as a string, so that it would treat the numbers into string and it would work out. No, it wouldn't create an error. Okay. So, and then the calculate weekly pay. So 20 times 15.5. I hope I multiplied it correctly. I think it's 310. Okay. So 310 for the salary for this week. Okay. So, well, you could actually use this. Um, you could implement this as a Java code in your machine. Okay. So if you have any question, class, that's all for now. If you have any questions, then you can send a uh, PM or direct message on my contact details. Okay, so that's it for now. Thank you and God bless.